Hi students, I am Xavier. Welcome to Ryan's Academy. We are studying Periodic Classification of Elements, Science Part 1st of 10th Standard. Last topic we studied Derivative Mendeleev. He developed the periodic table of elements. Mendeleev's periodic table states that properties of elements are a periodic function of their atomic masses. Now we are going to see the contribution of Henry Moseley in the periodic classification of elements. He gave modern periodic law. It states that properties of elements are a periodic function of their atomic numbers. Like Mendeleev's, Henry Moseley gave periodic table called modern periodic table or long form of periodic table. Structure of modern periodic table. Point number 1. The modern periodic table contains 7 horizontal rows called the periods and 18 vertical columns called groups. Below the table, there are two series called as lanthanide and actinide. Point number 2. The elements are arranged in their increasing order of their atomic number in modern periodic table. Point number 3. There are 118 places for elements in the modern periodic table. Point number 4. The periodic table is divided into 4 blocks, that is S block, P block, D block and F block. Group number 1 is called alkali metals. Group number 2 is called alkaline earth metals. Group number 3 to 12 are called transition metals. Group number 17 is called halogens and group number 18 is called noble gas or rare gas. The 3 traditional types of elements are separated by a zigzag line in the modern periodic table. All the metals lie on the left hand side of the zigzag line while all the non-metal lie on the right hand side. The metalloids lie along the border of this zigzag line. Comparison between Mendeleev's periodic table and modern periodic table. Point number 1. In Mendeleev's periodic table, there are 7 periods and 8 groups. In modern periodic table, there are 7 periods and 18 groups. Point number 2. In Mendeleev's periodic table, the elements are arranged in the order of their increasing atomic masses. In modern periodic table, the elements are arranged in the order of their increasing atomic numbers. Point number 3. In Mendeleev's periodic table, isotopes of same elements have same chemical properties but different atomic masses. They cannot be placed separately in the periodic table. In modern periodic table, isotopes can be placed at the same place as their atomic number is the same. Point number 4. In Mendeleev's periodic table, the whole number of atomic mass of cobalt and nickel is the same, hence there was an problem regarding their sequence in periodic table. In modern periodic table, this problem is solved as the table was prepared on the basis of the atomic number of elements. The atomic number of cobalt is 27 and that of nickel is 28. Therefore, nickel is placed after cobalt. Now we will see periodic trends in the modern periodic table. Certain regularities is observed in the variation of the properties of element in a period or a group of the modern periodic table. It is called periodic trends. First one, valency. Valency is determined by the number of electrons in the outermost shell of its atom, called as valence electron. As we move from left to right in the periodic table, initially valency increases and then decreases. For example, in period 2, the valencies are lithium is 1, beryllium is 2, boron is 3, carbon is 4, nitrogen is 3, oxygen is 2, fluorine is 1 and neon is 0. All the elements in the group have same number of valence electrons. For example, in group number 1, valency of element is 1. Hydrogen is 1, lithium is 1, sodium is 1, potassium is 1, and so on. Number 2, atomic size. The distance between center of atom and outermost shell is called the atomic radius. Atomic size is determined by atomic radius. In periods, atomic size decreases from left to right, and in groups, atomic size increases from top to bottom. In period, new electrons are added in the same shell, while in groups, the new electrons are added in the new shell. Point number 3. Metallic and non-metallic character. The tendency of an element to lose electrons from its outermost shell to form positive ion is called metallic character, and the tendency of an element to accept electrons in its outermost shell to form negative ion is called non-metallic character. In period, as atomic number increases from left to right and atomic size decreases, it is difficult to remove valence electrons, hence electronegativity and non-metallic character increases. In a group, as atomic number increases from top to bottom and atomic size increases, it is easy to remove valence electron, hence electropositivity and metallic character increases. As we move from left to right in the periodic table, the electronegativity and non-metallic character increases and electropositivity and metallic character decreases. As we move from top to bottom in the periodic table, electronegativity and non-metallic character decreases and electropositivity and metallic character increases.